I'm going to talk about the derivative of the natural logarithm function. I'm also going to talk about the alternate integral-based definition of the natural logarithm function. Okay? Let me start by deriving the derivative of the natural logarithm function. So, the first thing to remember is that the exponential function and the natural logarithm function are inverses. Okay? What that means, remember, is that their composition is equal to x. So e to the ln of x is equal to x. Likewise, the natural log of e to the x is also equal to x. All right? So now let's take the derivative of both sides. So using the chain rule, e to the ln of x times the derivative of the ln of x is equal to 1. So the derivative of the ln of x is, and I can divide both sides by e to the ln of x to isolate what I'm looking for. So that gives 1 over e to the ln of x. But we just established that e to the ln of x was equal to x. So this is equal to 1 over x. All right? So therefore, the derivative of the ln of x is equal to 1 over x. So please make a note of that. Let's use this new derivative formula now. So what is the derivative of the ln of the natural log of 5x? Okay, so using the chain rule, 1 over 5x times the derivative of 5x, which is 5. So apparently it's 1 over x. Okay? What about the derivative of the natural log of the sine of x? Okay, so that's 1 over the sine of x times the derivative of the sine of x, which is the cosine of x. So the most compact way that I could write that is the cotangent of x. Okay? Now, I'd like you to try to do an example. Would you please try to calculate the natural log of the square root of x? So pause the video and try to work that out now if you like. Okay, so I'll go ahead and work it out as well. So 1 over the square root of x times the derivative of the square root of x, which can be written as 1 over 2 times the square root of x. That simplifies to 1 over 2x. Okay? Would you please do one more example? Try to calculate the derivative of the natural log of 1 over x. Okay, so pause the video and do that now, please. All right, so I'll go ahead and do it as well. So the derivative, first, to calculate the derivative, first I'll write 1 over the argument, so 1 over x, times the derivative of 1 over x, which can be written as minus 1 over x squared. So now we can multiply the denominators together, and that gives x, so minus 1 over x. All right? Now I'd like to switch gears and derive the alternate integral-based definition of the natural logarithm function. Let me start with the derivative formula we've just derived. And I'm going to write it with respect to the variable t. Okay, now I'd like to integrate both sides from 1 to x. With respect to t. The left side integral can be found using the fundamental theorem of calculus. So the antiderivative of the derivative of the natural log of t is the natural log of t. So we're going to evaluate that at x and 1 and find the difference. And that's equal to 1 over x times dt over t. The value of the natural log of 1 is equal to 0. All right, because remembering our basics of logarithms, we know that any positive number raised to the 0 power is equal to 1. So for the left side, we just have ln of x, okay? And on the right side, we have the alternate integral-based definition of the natural logarithm function. All right? Sometimes this will be a handy formula to remember. So let me now use this formula in a few examples. Suppose we wanted to find the definite integral from 2 to 5 of 1 over x with respect to x. Okay? So that's equal to the integral from 1 to 5 minus the integral from 1 to 2 of 1 over x, okay, with respect to x. So the first integral on the right side is the natural log of 5. The second integral on the right side is the natural log of 2. The difference of natural logs can be written as the natural log of a quotient. So look at that. We did the integral and we got the natural log of 5/2. Okay? Let's do one a little bit more difficult. And by the way, I'm going to use this pattern a few more times where I have an integral with respect to two positive limits of integration, and it ends up that if I'm integrating the reciprocal of a variable, then the answer will turn out to be the natural log of the ratio of the limits of integration. Okay? Okay, so suppose we wanted to find the integral of the cotangent of x with respect to the limits of integration pi over 6 and pi over 2. So the cotangent of x can be written in terms of cosine and sine, so let's do that. And now let's try a u substitution with respect to u equal to the sine of x. And that then the derivative of u with respect to x is the cosine of x. So I can write the original integral as the integral of 1 over u with respect to u. And I'm going to have to change the limits of integration. The sine of pi over 6 is 1/2. The sine of pi over 2 is 1. All right? So now, using that pattern that I noticed where the integral of the reciprocal of a variable is equal to the natural log of the ratio of the limits of integration if they're positive. So that means that this is equal to the natural log of 1 over 1/2, or the natural log of 2. Now I'd like you to try to do an example. The integral of the tangent of x with respect to x from pi over 6 to pi over 3. Now, let me give you a hint. You might have success if you rewrite the tangent function in terms of the sine and cosine function. All right? So pause the video if you like and try to solve that now. All right, so I'll go ahead and solve this. So let me first rewrite the tangent function as the sine of x over the cosine of x. And let me now try a u substitution with respect to u equal to the cosine of x. And so the derivative of u with respect to x is minus the sine of x. So that means I can rewrite the original integral as minus the integral of 1 over u with respect to u, and I'm going to do that integral with respect to the following limits of integration: the cosine of pi over 6 and the cosine of pi over 3. Cosine of pi over 6 is root 3 over 2. Cosine of pi over 3 is a half. So there you have it. And so that gives minus the natural log of the ratio of those limits of integration. So 1/2 over root 3 over 2. And now we can simplify that fraction. The 2's cancel. So we've got minus the natural log of root 3 to the minus 1. And I wrote it that way to show that I can pull the exponent down, and so the minus 1 exponent will cancel with the negation there, and so I'll end up with just the natural log of the square root of 3. All right? Now, let me have you do one more example. Would you please try to find this integral? The integral of 1 over the product of x and the natural log of x with respect to x from e to e squared. So pause the video and try to do that now, please. All right, so I'll go ahead and do it as well. So I'm going to try a u substitution with u equal to the natural logarithm function. And so the derivative of u with respect to x is 1 over x. Therefore, I can rewrite the original integral as the integral of 1 over u with respect to u. And the new limits of integration will be ln of e, which is 1, and the ln of e squared, which is 2. Okay? You can check that on your calculator, or you can remember that the natural log and the exponential function are inverses. Okay, so you can think of the ln of e as the ln of e to the 1, okay, which has to give 1, and you can think of ln of e squared as 2, right, because you can pull the 2 down. Okay, so continuing, So this is equal to the ln of the ratio of 2 and 1, which is just 2.